Bismillahirrahmanirrahim. Assalamu alaikum dear students. It's your physics class today, and today we continue our numericals of unit number 3. So let's start from numerical number 5, which is two bodies of masses 3 kg and 5 kg are tied to a string which is passed over a pulley. Now here two masses are given to you, 5 kg and 3 kg. If the pulley has no friction, find the acceleration of the bodies and the tension in the string. Now you will find the acceleration and tension. Only two masses are given. And here the clue is given to you that the pulley has no friction and masses are tied to a string. So here you will write the formula for the Atwood's machine, because it is the structure of Atwood's machine. And here we find the acceleration and tension with the help of the formula of Atwood's machine. Now let's start. The given data is mass m1, that is 5 kg, because in Atwood's machine we have done that m1 must be greater than m2. m1 is 5 kg and m2 is 3 kg. Now the acceleration due to gravity, that is a constant value. It is also write in this numerical, that is equals to 9.8 fixed value. Required is the acceleration a and the tension t. Now the formula for acceleration is equals to m1 minus m2 into g divided by m1 plus m2, which we have already proved in the topic of Atwood's machine. And the tension T equals to 2m1 m2 into g divided by m1 plus m2. Now first finding the acceleration. Now for acceleration we write its formula, and by putting the values we get a equals to m1 5 kg minus m2 3 kg into g, that is 9.8 meter per second square, divided by m1 5 kg plus m2 3 kg. Now by subtracting these two masses in the numerator we get 2 kg, and now it is multiplied with 9.8 meter per second square divided by 8 kg, that is the addition of 5 kg and 3 kg in the denominator. Now kilogram is cancelled with the kilogram, and we when we multiply 2 into 9.8 and dividing by 8 we get 2.45 meter per second square, that is the acceleration. Now for the tension we write its formula, and by putting the values of the tension we get 2 m1 5 kg m2 3 kg into g 9.8 meter per second square, and in the denominator we have m1 5 kg plus m2 3 kg. Now by multiplying 2, 5 and 3 we get 30 kg square into 9.8 meter per second square divided by the addition of 5 kg and 3 kg is 8 kg. Now kg is cancelled with a square, and when we multiplied 30 kg with 9.8 meter per second square and dividing by 8 we get 36.75 Newton. Now it is the value of the tension. Now the result is acceleration a, that is 2.45 meter per second square, and the tension t equals to 36.75 Newton. Now numerical number 6. Determine the magnitude of the centripetal force exerted by the rim of a car's wheel on a 45.0 kg tire. Now here the mass is given to you, and determine the magnitude of centripetal force. We will find Fc, centripetal force. The tire has 0.480 meter radius. Radius is also given, and is rotating at a speed of 30.0 meter per second. Speed is also given to you. Now our given data will be mass m equals to 45.0 kg, radius r equals to 0.480 meter, speed v equals to 30.0 meter per second, and our required is centripetal force Fc equals to question mark. For centripetal force we have the formula Fc equals to minus mv square divided by r. By putting the values we get m 45 kg and v 30.0 meter per second whole square divided by r 0.480 meter. Now the square of 30 is 900 and the square of meter per second is meter square per second square, and this meter is cancelled with the square, and when we multiply 45 with 900 and dividing by 0.48 we get minus 84375 Newton. Now this negative sign shows the opposite direction of the force, and the centripetal force is equals to 84375 Newton. Numerical number 7. A motorcyclist is moving along a circular wooden track of a circus death well of radius 5 meter. Now radius is given to us and with speed that is 10 meter per second. If the total mass of motorcycle and the rider is 150 kg, mass is also given, and here we also find the magnitude of centripetal force. Again same formula. In the given data, we have radius r 5 meter, speed v 10 meter per second, mass m 150 kg, and required is centripetal force question mark. Formula is same, F equals to minus mv square by r. By putting the values, we get m 150 kg, v 10 meter per second whole square divided by r, that is 5 meter. Now the square of 10 is 100 and the meter second is meter square per second square. Now meter is cancelled with the square, and when we multiply 150 with 100 dividing by 5 we get 3000 Newton. Now this negative sign shows the opposite direction of the force, and our result is centripetal force Fc equals to 3000 Newton. Numerical number 8. A car of mass 1000 kg is running on a circular motorway interchange near Sawabi with a velocity of 80 meter per second. The radius of the circular motorway interchange is 800 meter. Here you notice that here is 2 mass is given, velocity is given, and the radius is given, and how much centripetal force is required. So the given data is mass m 1000 kg, velocity v 80 meter per second, radius r 800 meter, and the required data is centripetal force Fc equals to question mark. Now the formula for centripetal force equals to minus mv square by r. By putting the values of the centripetal force we get m 1000 kg and v 80 meter per second whole square divided by r 800 meter. Now here the square of 80 meter per second is equals to 6400 meter square per second square. Meter is cancelled with the square, and when we multiply the 1000 with 6400 and dividing by 800 we get minus 8000 Newton. That is the magnitude of centripetal force. Now here is 2 minus sign shows that force is in opposite direction. Now our result will be centripetal force Fc equals to 8000 Newton. Now these are our numericals, and till the next class, Allah Hafiz.